Okay, on this lesson we're going to be solving our absolute value equations and then also inequalities by graphing. So we've been solving them algebraically, now we're going to graph them and solve them. So the process for this, it says graph the left side and the right side separately, and then you're going to identify the point of intersection or points of intersection. You're only using the x values because when you're solving, what we've been doing, we've been solving for x. So you're looking for those x values. All right, so if we look at number 1, we're going to look at just the left side. So just the left side, this would be shifting our parent function left 5. That's what we've been working on. So I'm going to go ahead and graph that. The slope is 1 over 1, so up 1, right 1. And then we want a V, so up 1, left 1. And then we're going to do the same thing, but now we're going to graph the right side. The transformations from your parent function would be a vertical stretch by 2 and then a left 2. So I'm going left 2 for my vertex. And then I'm stretching by 2, which is really your slope. So up 2, right 1, up 2, right 1, up 2, right 1. And then the opposite, we want a V, so up 2, left 1, up 2, left 1. So we graph each side separately, and then we're trying to find our points of intersection. So notice that would be here and here. So we need to find those points. That would be -3, 2, and this one would be 1, 6. All right, so we're solving for x. So when you're writing your solution, you're just looking for your x values because there's no y values in our equation. So your solution would be x equals -3 and 1. So write it as a solution set. So use your curly bracket. Smallest goes first, -3 and 1. So those are your two x values. All right, so let's take a look at number 2. So we're going to, again, solve it graphically. So we're going to graph the left side, and then we're going to graph the right side. So left side, we have a negative, so that's reflected over the x-axis. And then stretch by 2. And right, or left 7, sorry. All right, so we're going to go ahead and shift it. So we're going to go left 7, 1, 2, 3, 4, 5, 6, 7. There's my vertex. And then my slope is -2. Because of the reflection, it's -2. So I'm going to go down 2, right 1, down 2, right 1, down 2, right 1. And then the opposite would be down 2, left 1 in order to finish out your V on your absolute value. All right, so now notice, I use this one's pink, and I'm gonna use purple on this one, my bad. All right, so notice on this side, it's just a constant. That is just telling me that all of my y values are gonna be 5. So that looks like this, 1, 2, 3, 4, 5. Go to where y is 5 on the y-axis, and it's just a straight line. So we're just y equals 5, and it's a straight line. That's a constant graph. All right, so remember, when we're solving these, we're trying to find the point of intersection. Notice there is not a point of intersection, which means there's no solution here. You can use the symbol. All right. Looking at the next example. Now you don't have to write your transformations down as long as you know what happens. So this is going to be left 1, and this will be down 2. So go ahead and shift your vertex. Left 1, down 2. And then our slope, notice in the very front is a 1, so go up 1, right 1 with it. And then we need to finish the V out, up 1, left 1. Oh, that line is not straight. Okay, and then graphing the right side, it's just a 4, so go to where Y is 4. And it's just a straight line, so we're finding the points of intersection. So notice it intersects at this point and it intersects at this point. So we need to find those points. So that would be 1, 2, 3, 4, 5, 6, -7, 1, 2, 4. And the other one would be 1, 2, 3, 4, 5, 4. So again, when we're solving these, we're just looking at the x's because there's no y's in our equation. So my solution would be x equals -7 and 5. So those are the two values. You can easily check these by just plugging them in for x and making sure the equation is true. So this is solving an absolute value equation graphically. Okay, so looking at my number 4, so I'm going to go ahead and graph the left side. So the left side is going right 1 from our parent function, so go right 1 with it. There's my new vertex. And then my slope, look in the front, is 1, so go up 1, right 1. And then up 1, left 1. To finish your V out, it's absolute value. You should always have a V when you have absolute value. It could have possibly opened down if it was a reflection over the x-axis, but it should be the shape of a V. All right, so looking at the right side, notice this one is linear. So we're going to use the slope, 2/1, and the y-intercept, -4. You can also think of it as a vertical stretch by 2 and then down 4. So however you want to graph it. So down 4, 1, 2, 3, 4. And our slope is 2/1, up 2, right 1, up 2, right 1, up 2, right 1. You're looking for your point of intersection. Notice they do intersect. It's at 3, 2. So remember, we're just looking at the x. Now notice on this one that it's only one intersection, which means you'll only have one answer here. So our solution set would be a 3. So sometimes you have 0 intersections, sometimes you have 2, and then sometimes you just have 1. Okay, so let's take a look at the back. The back is very similar to what we were doing on the front, but this is inequalities. So the front, we just had equations. We were just looking to see what x equaled. So we're still going to be graphing it the same way. We'll graph the left side, we'll graph the right side, but we will have to determine whether to shade above or below for the intersection points in order to find your solution. Okay, so what we're going to do is we're going to graph this left side. So it's going to go down 5, your vertex, 1, 2, 3, 4, 5. And then a stretch by 2, which is your slope. So go up 2, right 1. Up to left 1, it's a V. Okay, and then the right side, y equals 7, so we're going to cross the y at 7. 1, 2, 3, 4, 5, 6, 7. I probably should have finished my points there. So that's my point of intersection at those 2 points. So that's -6, 7, and this one is 6, 7. Okay, so we only care about the x values, so we'll only look at your x values. Now, we're going to have to shade based on our inequality sign. Anytime it is a greater than, so the left side is greater than, we're going to be shading above that straight horizontal line. So the shading part will probably help you. So we're only shading the portion of the V that is above the horizontal line. So those are going to be our solutions. So all those x values that are going to the left of -6, all the x values that are going to the right. There's a couple of ways of writing your solution here. So since we're at -6 and it's going to the left, that would be everything less than -6. How you know it will include it or not is look back at your original inequality. It includes it there, which means it'll include your intersection point. Or if you look at it, x is 6 and it's going to the right, so x is getting larger than 6, and it also includes it there. So if you remember when we were solving these algebraically, notice here that when I shade above, I have to pick up my pencil. Those are separate, which means they will be separate when you write it, so it will be an or statement. Another way of writing it, we can use interval notation, which we talked about on the domain and range. You can do on the left side here, -infinity to -6, and it does include it. And then it's called like a union, so you'll just put like a U there. And then the other one will be from 6 to +infinity. It does include 6. So I'll accept either answer here. Now, it wants us to record the solution set and then represent your solution on a number line. So you can also do that. We have 0, -6, 6. It's less than or equal to -6, and greater than or equal to 6. So there's your solution. So I'll accept this answer or this answer. You don't have to put both. So you'll have both of those on the key there. Okay, let's take a look at the next one. So we're going to graph the left side. So that's going right 5. 1, 2, 3, 4, 5. That's it. That's the only thing that happens. The slope is still 1. So up 1, right 1. Opposite would be up 1, left 1, because it's absolute value there. Now, depending on your intersection points, you might have to keep going with your points. You'll just have to check. Now, this one here is just going to be crossing the y at 4. 1, 2, 3, 4. It's just a straight line. And it intersects at this point and this point. So that is 1, 4, and 1, not 1, 9, 4. Okay, so we will need to shade it based on the inequality. It's a less than, so you're going to be shading below that horizontal line. So make sure you only shade that portion of the V, so that way we know what our x values will be. So pay attention to your x values. We know it's going to include everything based on our shading, everything between 1 and 9. So when you write your inequality, you'll have an and statement. So 1 is less than, x is less than 9. How you know it includes your intersection points, look at your original. It's not equal to there, so it won't be equal to on your solution. Okay, so since this is all together, if you wanted to use interval notation, it starts at 1 and it goes to 9, and it doesn't include them, so you'll put parentheses. So again, I'll accept either answer. And then when you're drawing your number line, you have 0, 1, and 9. They should be both open points. It's greater than 1 and less than 9, so they should connect. If you remember us doing this algebraically, if it's an and statement, it would be connecting. Notice here when I shaded, I didn't have to pick my pencil up, so it's all together, which means you should have an and statement for your solution, okay? Or you can write it using interval notation, either way. All right, let's take a look at the next one. So we have All it's doing is going up 8 on the vertex, so go up 8. Slope is still 1, so up 1, right 1. Up 1, left 1 to form your V. And then this right side is a 3, so it crosses the Y at 3, and it's a straight horizontal line. All right, so less than, remember we said less than was shaded below. First off, I noticed that there's no intersection points. I would need to shade below. Notice none of that is a portion of our V there, so this is a no solution. You can actually look at it. When I take the absolute value of a number, I'm going to get positive. I add 8. That's never going to be less than 3 if I'm adding a positive number to 8. It's always going to be greater than 3. That's why there's no solution there. All right, last one. So this one here, we have a reflection, and then we have a right 2. So I'm graphing going right 2 on my vertex. And then I'm going down 1, right 1 because the slope is negative in front because of the reflection. Opposite would be down 1, left 1 because I need to form that V. And then my right side is just a 4. It crosses the Y at 4 and just a straight line. Okay, so it says, notice it says less than or equal. Read it from left to right. So less than or equal, you will be shading below that straight horizontal line. So when we shade below, notice it's the whole V. So if it's the whole V, that means that would be all real numbers, or you can use the symbol for that. Now let's pay attention to our inequality. Notice here we're going to take the absolute value, we're going to get a positive, but all of our answers are going to be negative because of that there. So it's saying what could we plug in for x to get something less than or equal to 4? Well, this is always going to be less than or equal to 4 because that's going to make it a negative. So a negative number is always going to be less than or equal to 4. That's why it's all real numbers we could plug in here. Okay, if you have any questions on solving these graphically, please let me know.